My name's Nathan, and I'm here to show how we kind of came up with the idea for the Lego City and the Smart City Connected City setup. So here I'm kind of showing how we standardized our setup here in the Chicago office. Basically, we have our city in two pieces. We have our front-facing piece that has all the buildings and train and road pieces that face the front. And this was originally designed because we were at Avaya Engage, and the Avaya Engage booths only had about 4 feet of space in the front, if that. Actually, no, it wasn't even 4, it was more like 2. But the idea was that we were only going to have half a city, so the train actually wouldn't even go around the track. We decided that it's a lot more fun when the train kind of goes because it shows a little bit more automation to the city. So here we actually have built the city out to have 2 pieces, the front and the back. So you can see the train's going around and around, and the train has the variable speed due to the controller. We've all kind of valued showing the same set so you can kind of understand how this controller works. I don't usually like to have the train going around too fast because I think that's too much of a distraction to the customer, so I kind of go for a little bit of the lower speed, just enough to kind of give the automation to give the city a little bit more life. The biggest thing we came up with for the train is that it has a sensor that actually lives inside the train that runs even though the train isn't connected via USB or micro USB. Because all of these other sensors are connected via micro USB to a central USB hub, but since the train has to go around the track, we couldn't have a wire going around the track. So the idea we came up with was to have the top of the train come off, and inside you can actually see there's the sensor that's living right there, connected to a power cell that you would use to charge your cell phone traveling. So that power cell is actually then powering the sensor in there, and so that way the train can actually run around the track and not have to be tied down to a power cable. That's one setup I recommend for the train environment. A lot of other recommendations I have are to kind of determine what your exact customer outlook is, what vertical they're a part of. You want to know exactly how to relay the information of the Internet of Things, because train derailments might not make sense to a healthcare or hospitality company. That's just kind of my idea that we had. The original idea for this whole setup actually came from a train company, so that's why we kind of centered it around the train derailment scenario. But also we have here, besides the train derailment, we have on top, we have a sensor waiting for a power outage. This one's actually just based on light, so when I throw something such as a blanket here, I call this my blanket power outage, or blanket blackout you could say. And when you throw it over the sensor, it actually then triggers based on light. So it's not determining voltage or anything else, it's just the light sensor. But that kind of gives the effect of, you can speak to the voltage versus having to connect wires to it, you can just throw a blanket over it. It makes it a lot simpler. Another example we had is the smart parking. So using the cross 4-way pieces, we actually just then have the smart parking spaces kind of the crosswalks of those 4-way intersections. Makes it kind of look like a parking space, close enough. And then I just taped down the sensor, plugged in right there, and that one's also based on light. So the light will then trigger the Breeze workflow. You can control all that telemetry based in the Aero-Connect Lab. So those two are both based on light. So when the light level's too low, that's when the Aero-Connect then makes a post call to the Avaya Breeze Lab. And I forgot to mention the train is actually accelerometer. So it's detecting, the sensor is actually standing tall ways, and it actually detects when the sensor goes either on its front side or its back side. And that's I believe the accelerometer X position. So that's what it's determining that the train's tipped over one way or the other based on the accelerometer X. I believe I have it listed as going over or under 1. I can't remember exactly, but just to get an idea of what I kind of did for that. The other two that are similar are the car accident and then the patient inside the hospital. Both of those sit upright, and when they determine that they're anything from sideways or upside down, anything that's not facing upright, that's what's triggering the workflow there. And that's accelerometer Z. So those are both going to wait for accelerometer Z to reach the threshold of, I believe, 0.6. I can't remember the exact numbers. But that's just kind of give an idea of when the car rolls over or when the patient falls out of bed, the bed tips over. That's what's going to trigger the Breeze workflow using the Aero-Connect Lab. All of these sensors, kind of work together. We've determined that the exact threshold for Bluetooth low energy is 7 sensors. Cannot go over 7. I don't recommend 7. I recommend 6 to people because once you hit 7, there's a lot of I believe it's just bandwidth issues, especially with this Tech board. So the Tech board is what we've been recommending to people. It's the little black board that has the basic connectivity of low-level Bluetooth. It runs the Debian Ubuntu software and has just simple USBs in the back and HDMI and power and Ethernet. That box is actually just kind of it's a glorified cell phone almost. It doesn't have a whole lot of processing power. So when you add more than 6 sensors, that 7th sensor actually kind of takes up a little bit more bandwidth, and I've run into issues with the telemetry not getting there. There's a lot of things you can play with inside of the AeroConnect Lab, and playing with the properties files that go with the sensors. So those property files, you can determine how many times the sensor pings out to the AeroConnect Lab, and you can determine how many times the sensor and the gateway have a heartbeat to determine that connectivity is still live. For the sensors, I only have them pinging out data every 2 seconds. You can do almost, I think, every 10 milliseconds. I think it lets you go up to, and that's super fast. I don't think it's even necessary to have things that fast because everything in this demo is kind of just triggered on the event. The event happens, very slowly. It's not anything that requires that high of telemetry. So I go every 2 seconds. I recommend. Other things we kind of do to keep things smooth is we make sure that we can stay hardwired to the internet if we can. Wi-Fi works okay, but we've ran into a couple issues when using hotspots or using corporate Wi-Fi or using a guest Wi-Fi when we're out on a road show or out demoing somewhere else. So to actually combat going out traveling and having connectivity problems, for our demo here, we actually purchased a Cradle Point. If you want to come back here, the Cradle Point is a very cool device that actually uses a cell service provider to then give internet to all of our devices here, our Vantages, our Tech board, my laptop, everything. It uses 4G wireless. In this exact one, we're using Verizon as our service provider, and we'll actually, connect everything either wirelessly or it also has ports in the back for Ethernet. So right now I have my Tech board plugged in by Ethernet, and I also have my Vantages plugged in by Ethernet. And since those ports are also PoE, my Vantages actually do not require any sort of powering cable. They can actually just be plugged in via the Ethernet cord. I'm trying to show it as an example here. That's kind of all given examples of how we worked around connectivity, because it's tough when you go out to a customer site or a road show, something that's you're not really sure what the network environment's going to be like. It's pretty important to have some sort of connectivity option. So we decided that the Cradle Point was the best. I like it a lot. It's worked very well so far. We have had almost no issue. There's been a couple of snags when trying to get it on the corporate data plan, but that's something else. But with connectivity, other than that, it's great. As part of my lists, I also listed off having our USB hub in the back here. And the USB hub is what you use to actually power all of the sensors via the micro USB cables. So here you can see I have these silver ones. I mean, you can use any sort of micro USB cable. Here I have 3-foot and 6-foot ones. The further away ones use the 6-foot, and the ones that are super close to the hub use only 3-foot. That's for power. If you haven't noticed on the sensors, there's 2 lights. There's the green light and the blue light. The green light is to determine connectivity, and the blue light is to determine power and data transmission. So what's kind of interesting about these Silicon Labs, here we're using Silicon Lab Sense 2s. The Silicon Lab Sense 2, the blue light actually determines power, but if it's power without a data connection to either a laptop or a Tech hub, it will actually flash. It'll strobe the blue light instead of being a solid blue. So what I recommend is that when you have your USB hub, to actually have that USB hub plugged into your Tech board. That way your little sensors are not going to strobe the blue, they'll stay solid blue. So when they stay solid blue, it's a little less distracting. It's a lot more, my screen fell asleep. It's a lot easier on the eyes to look at when it's just solid blue. And that's just all based on whether or not it has a data connection to either a laptop or any other device that supports USB. The green light is to determine connectivity to the Tech hub or whatever other hub or gateway you're using. So the green light will actually flash when it's not connected. So that green light flashing means that it's searching for a connection, and will only flash for 30 seconds. It'll actually, every flash is 1 second. So if you see your green light flash 30 times, that means it has not successfully connected to whatever gateway you're using. So here we have our little sensors laid out, and I recommend if it flashes more than 10 times, just disconnect it and try to reconnect, because if it goes over 10 seconds, it's more than likely something's not connecting right. But if it flashes 30 times, that means nothing's connecting at all. So you have to check, check your gateway, check your internet connection, any other sort of help that way. Some things we ran into is that if you don't have a solid internet connection, the gateway will connect fine, but the sensors will not connect. I've ran into a couple issues where if the internet connection doesn't have enough bandwidth, I'm not sure exactly what it is, but if it doesn't have the correct connections, the gateway may connect and the sensors won't. It's kind of a game of balancing it out and trying to make sure everything connects to show that level. I'm trying to think of what else to list. My 3 screens I have here are all basically to show everything that I have tied in with our demo that we use. So in our examples, I use my iPhone, which is connected via HDMI adapter. The middle screen I'd like to show the telemetry of information on the AeroConnect Lab. So you can either show it in real time. My sensors are offline right now, so I'm not having any telemetry come in. But it's nice to show the telemetry come in and then maybe show the data dip when the data dip hits, or the telemetry dip. So when that telemetry dip happens, that's what triggers the Breeze workflow. Sometimes it's nice to show that in the middle screen, or you could show maybe a big notification screen saying this is what we're showing here. Here's the Internet of Things, or a PowerPoint you can show as well. On the right side here, I have an Oceana Lab that is actually waiting for me to call in from a direct dialing number from the mass notifications that I send out. So when you click on the mass notification, actually those direct dialing numbers are actively connected to one of our Oceana Labs. So here, our Oceana agent's just waiting for a call or a text, and I can use that all using my cell phone on the left over there. Also, I have a ServiceNow Lab waiting, and the ServiceNow Lab is actually waiting for train derailments and train laps. So when the train derails, there's a certain ticket that gets put in based on the train derailment, giving there was a train accident. Also, in my example, I have a sensor sitting under my track that actually counts how many times the train goes around the track. And on the 10th time the train goes around the track, it actually puts in a different type of ticket versus just the train derailment ticket. Kind of gives an example. We're not hard coding everything. We're trying to show dynamic events, trigger dynamic, different types of dynamic workflows. So that's a good instance you can show. So here I have my ServiceNow Lab. You can sign up for ServiceNow Labs just by going to dev.servicenow.com, I believe, and you get a free ServiceNow Lab. Same goes for AeroConnect. You can sign up for a free AeroConnect account by going to aeroconnect.io. That's free as well. The Oceana Labs are something that are controlled by Demo Avaya, so that's something you need special permissions for. But the AeroConnect and ServiceNow are free and free for anyone's use. Lastly, I forgot to mention the Vantages. Originally, I had 4 Vantages on hand, so we just happened to use 4 Vantages for the demo. Not required to have 4. I recommend at least 2, because then you can show calls between 2 different entities of government agencies or companies. For our examples, we have emergency services, we have a drone live feed, and we have an insurance company and electric company. The 2 that are used in a lot of ours here, because we have a power outage and a train derailment, are the dispatcher, emergency services, and the electric company. Those get used quite a bit. The drone live feed is to show the live feed in the collaboration room. So what I actually do is I have my laptop sitting and waiting, and I have my webcam, I have a webcam attached to my laptop that just basically sits in my collaboration room and waits. Because I can't fly a drone normally wherever I am, on a trade show or wherever else. I just have the drone simulate or the webcam simulate the drone and sit in the collaboration room, and then those 2 teams then dial into that collaboration room to get the live feed. So it's kind of simulating the live feed in real time, but realistically, I'm not having a drone fly to the GPS location. So that's kind of showing a couple examples of how we came up with some of the ideas. I got a little technical here and there to show more in depth of what we came up with, but a lot of this is used using Demo Avaya's Lab 111. Or Demo Avaya's Lab 104. If you're outside of Avaya, you might have your own Demo Avaya collaboratory. Part of the collaboratory is where I host all my workflows, and I also have the SQL database that connects the mass notifications that get sent out to all the civilians. So basically it's a notification database listing all the cell phone numbers and names of everybody who's subscribed to it, and then does a mass text based on all the numbers that are currently subscribed to the notification. So that's using the SQL database inside the collaboratory. Yeah, all of this is working together to show the Internet of Things working with Avaya Breeze, the Avaya Breeze workflow engine, trying to take the telemetry of information that come from the sensors and then relaying that information to the right people in real time. That's the story we're trying to go with in showing the Lego City, or Connected City, in this case we're trying to show. Good luck to everybody. It's very fun to see how many people are going out there and actually building Lego cities of their own. I believe all of the Avaya EBCs are going to have Lego cities now, and I see a lot of partners are taking the initiative and showing Lego cities as well. So it's very cool to see the initiative and see all the people building these together. So keep up the good work, and best of luck to you.